All right, today we're going to break down a term you hear all the time, but maybe don't think too much about: ICT. That's Information and Communication Technology. And trust me, it's the invisible engine running basically everything in our modern lives. By the time we're done here, you're going to see how it all fits together. So let's jump right in.
Seriously, have you ever just stopped to think about it? You tap on a piece of glass, and almost instantly, someone on the other side of the planet can see your message. It feels like actual magic, right? Well, it's not magic. It's an incredibly complex, high-speed dance of technology, and we're about to learn the steps.
The best way to get your head around ICT is to think of it as a digital ecosystem. You've got the physical parts, you've got the brains giving all the instructions, and you've got the network that connects everything. And just like in nature, every single part relies on the others to work. Take one piece away, and the whole system can grind to a halt.
So, let's start at the very foundation of this ecosystem, the hardware. This is the stuff you can actually, pick up and hold.
When we say hardware, we mean all of it. From the obvious things like your screen and keyboard, to those tiny, ridiculously powerful little processors humming away deep inside. It's the physical body of our digital world.
So how does this body actually do anything? Well, let's follow a single command on its little journey. First, you provide an input. Say you click your mouse. Next, the central processing unit, the CPU, which is totally the brain of the operation, it processes that command. Then, it uses memory and storage to grab any data it needs, and finally, it gives you an output, the result you see on your screen. Input, process, store, output. That simple loop, it's happening millions, even billions of times a second.
Now, digging into that memory part, there are two key types you gotta know. Think of RAM as your desk. It's the temporary workspace for everything you're using right now. But as soon as you turn the power off, poof, the desk gets wiped clean. ROM, on the other hand, is more like the printed instruction manual for the device. It has the permanent, unchangeable instructions your computer needs just to wake up and start. It's always there.
Okay, so what happens when your own hardware isn't quite enough? Well, that's where the cloud comes in. And really, all cloud computing means is that you're basically renting someone else's super powerful computers over the internet. So when you save a photo to Google Drive, you're not sending it to some magical place in the sky. Nope, you're saving it to a physical hard drive inside one of Google's massive, real-world data centers.
All right, so we've got the physical body, but a body's not much use without a mind to tell it what to do. So now let's move up to the next layer of our ecosystem, the software and the data that give all that hardware its purpose. Simply put, software is the director of the whole show. It's the set of instructions that tells the hardware, our actors, precisely what to do and when to do it. Without software, your smartphone is just a really pretty, really expensive paperweight. The software is what brings that hardware to life. Now, not all software is created equal. You've got two main kinds. First, there's system software. Think of your computer's operating system, like Windows or your phone's iOS. This is the behind-the-scenes stage manager, making sure all the hardware components are working together smoothly. Then you've got application software, what we all just call apps. These are the stars of the show, the programs you actually use to get stuff done, whether it's sending an email or playing a game.
And let's be honest, we use these apps for literally everything. For getting work done with Word, for keeping in touch with WhatsApp, navigating with Google Maps, you name it. These apps are our main entry points into that whole ICT ecosystem. So what is all this hardware and software actually working with? Data. And data has this really neat structure, kind of like building blocks. It all starts with the smallest possible piece, a bit. Just a single 0 or a 1, that's it. Put 8 of those together and you get a byte, enough to represent a single letter, like A. Bytes combine to form a field, like a name. Put related fields together and you get a record, like a full contact in your phone book. A bunch of records becomes a file, and an organized collection of files is a database. It's kind of amazing. Every single thing you see on a screen is just built from billions of those simple little on or off switches.
And how we manage all that data is a huge deal. Back in the day with older file systems, things were messy. Data got copied and duplicated all over the place. So if you moved house, you might have to update your address in 20 different files. A modern database, or DBMS, solves this problem by centralizing everything. You update your info in one single spot, and it's fixed everywhere. This isn't just more efficient, it's absolutely crucial for data security and privacy today.
Okay, we've got the body, the hardware. We've got the brain, the software. Now we need the nervous system to connect it all together. And that's where networks come in.
At its heart, a network is just a bunch of connected devices that can talk to each other and share resources. That resource might be an internet connection, a file, or even a printer.
The whole point is communication and sharing.
And networks come in different sizes. Your home Wi-Fi, that's a perfect example of a LAN, a local area network. It's a small network just for the devices in your house. A WAN, a wide area network, on the other hand, connects devices over huge areas, like across cities or even countries. And the biggest, baddest WAN of them all, well, that would be the internet. So who directs all this data traffic? Meet the traffic cops of the internet. A switch works inside your local network. It's like the mail clerk in your office building, making sure a document from you goes to the person in the next cubicle, not someone on another floor. A router is the big-picture logistics expert. It connects your entire network to the outside world, figuring out the absolute best path for your data to travel across the globe to a totally different network.
So, we've got hardware, software, data, and networks. But why should you care? Let's bring this all together by looking at the one device that perfectly captures this entire ecosystem: your smartphone.
The magic word here is convergence. Just think about it. Your phone isn't just a phone, is it? It's a powerful computer with complex hardware. It runs layers and layers of software. It processes tons of data, and it's connected to local and global networks. It's like dozens of separate technologies all got mashed together into this one seamless device that fits in your hand. Pretty incredible.
And just look at how we use them. Every single slice on this chart depends on that entire ecosystem working perfectly. When you're communicating, your messaging app is telling the phone's hardware what to do, and your router is sending that data out over a global network. And all of that happens in less than a second.
3 to 5 hours. That's how much time a lot of us spend swimming in this digital world every single day. So, understanding the layers that make it all possible, well, it's not just a technical exercise anymore. It's about understanding a huge part of modern life.
And this all leads to a final big question for you. We've mapped out the ecosystem as it stands today. But with AI making our software smarter, the Internet of Things connecting more and more hardware, and 5G making networks crazy fast, what part do you think is about to have its world turned upside down? The truth is, a change in one area is going to create a tidal wave through all the others. So the real question isn't just what will change, but how are we all going to adapt when it does?